Welcome to lecture 42, Standard Template Library. We call it as STL. Right, in the last lecture, we talked about vector and list. All right, if you recall, we have seen the programs also. And in this lecture, I'll start with deck. Right, so deck is nothing but double ended queue or doubly ended queue. All right. So, this is a dynamic array where you can do the insertion and deletion at both ends, right. So, you can see many practical situations, right. So, where someone does not follow the rules, all right, it is like they enter in the first, right, and a genuine person enter in the last, right. So, that is nothing but doubly ended queue or deck. So, this is also allowing the random access, like exactly like a vector. So, we can have a random access over here, right. So, it allows a random access, and there are several operations we can do like vectors and lists. So, here we can have push friend or insert friend, right. So, that means you can add an element in the beginning and push back, right. So, you can add an element at the end, right, end of the queue. Pop friend, right, delete friend, right. So, that the meaning is, so you can remove the first element and pop back, delete back, right. So, that means you are removing the last element. So, in fact, when you want to have fast insertions, right, the practical applications, right, there are cases if you require the fast insertions and deletions in both the ends, this particular data structures is being used and you call it as doubly ended queue or deck. So, now we will take an example. What I will do, I will include deck, right, hash include IOStream and hash include deck, and under deck class it is an integer, we take numbers, all right. So, numbers is an integer, it is coming under deck, okay. Numbers is an object, numbers is an object coming under deck, the objects as the integers. So, now you can see, right. So, we have advantage over here to take the member functions, right, inbuilt functions, inbuilt member functions. So, numbers, the object is invoking push underscore back, right. So, when it is invoking push underscore back, so this is initially empty queue. So, we are inserting, right, 10, the first element, push back or front does not matter because it is a empty queue. So, 10 will be here, right. So, next one numbers dot push front, right. So, push front, so we are pushing over here 5, right. So, pushing over here 5, I am not writing any pointer or something over here now, so it is understood 5, 10, it will be like this. Now, numbers will invoke push back by inserting 15. So, it will be like this. So, here you have 15, correct. So, now if you look at the queue, right, so it is a deck. So, 5 inserted in the front and 15 inserted in the back, and you can see, so this is the deck, right. So, this is a deck, right. So, the usual way what you do, queue is that first is the element 10, next you are inserting 5 and then 15, your usual queue we know that, right. So, usual queue if you take, right. So, usual queue what would have happened, it would be 10, 5 and 15, right. So, that is the usual one, but whereas in the case of a deck, so this is possible. So, when we have the inbuilt functions like push underscore back, push underscore front, right. So, we can insert like this. So, now we have to forget this. So, our deck is nothing but this. So, this is our deck, right. So, now we are printing, right. So, numbers, the object base address, now num will point, and when you are printing num, correct. So, it is an integer, correct. So, this is an integer num, and address of num will point to the base address numbers, and then when you are printing number, all the elements will be printed, right. So, 5, 10, 15 this will be printed, right. So, we will continue, you will have one endl, that means a new line. So, now I am doing pop front, alright. So, when I do pop front, so what will happen? So, here you go pop front, right, that means delete the front element. So, when I delete the front element, this will go off, right. So, that is the meaning pop front for line number 18, and line number 19 pop back. So, that means I am deleting 15 as well, correct, pop back, delete the last element. Now, I print num, right. So, the numbers, the base address is assigned to the address of number, and then when you are printing the number, So, you will get this particular output. So, that means we are getting 10, right, and then you have endl return 0. What we can do, we will check whether we are getting this output. So, I will just go to C++ compiler. So, this is an example, right, the same I have explained. Line number 19, you see pop front, pop back, and yeah, the same program. Let us run the code. So, when you run the code, you can see the output, right, what you are getting 5, 10, 15 and then 10, right. So, developer C++ we are running and you are getting the output. So, this is how the doubly ended queue, right. So, doubly ended queue works. So, when you are studying a data structure, you have to write the code pop front and pop back, right. So, the advantage of STL here is once you are including DEC, right. So, you have the option to use the inbuilt functions under DEC, push back and push front, right. So, this is how the doubly ended queue is working. So, next, what do you mean by associative containers, right. So, associative containers, what it will happen like set, right. So, mathematically when you define a set, assume that when A is equal to, let us say 3, 2, 3, 4, 5 and 5, right. So, we know that when I am representing this, right, A, like let us say 3, 2, 4, 5, I am still right, because the elements are repeating, 5 is repeating, 3 is repeating, and we know the basic mathematical definition of a set, it will be unique. And in the case of associative containers, so there is some property, it will write it in sorted order, right. So, in fact, so we will get, right, in the case of associative containers, we will get 2, 3, 4, 5, this is also same, both are same, all are same, right. But this will follow the associative containers in this C++ follow this, alright. And also, so with the help of keys, I can easily retrieve what are all those numbers, alright. And in fact, it is having some ordering base, this is what I explained in the set notation. So, it is using some ordered base. What operator is being used? The less than operator is being used. So, based on this, for example, initially I gave 3, 2, 3, 4, 5, 5, right, but it will keep like 2, 3, 4, 5, that is the meaning of the second point, right, internal ordering, right. So, associative containers, so we can classify like set, multi-set, map and multi-map. So, set stores the unique key in sorted order. You can see the unique keys 2, 3, 4, 5 and they are in sorted order. This is an example. Whereas multi-set, it allows duplicate key also, alright. For example, this particular case when I write it as a multi-set, so A will be equal to, right, I am explaining the multi-set, A will be equal to 2, 3, 3, 4, 5, 5, that is the meaning, right. So, it is also allowing duplicate key, you can see 3 are duplicate, 5 are duplicate, and then it will be in sorted order, that is the meaning, alright. I hope you understand. Then map. So, map stores key value pairs. So, you can have a pair, right, let us say 2, 3 or bala, 50. So, one is the string, another is the age, right. So, it will keep the pair and you can have the unique keys, right. So, you can have the unique keys. So, when you are representing, you will have the unique keys. So, unique in the sense, for example, when you are joining the institute or college or university, you will be given the enrollment number which is unique, right. So, it will have the pair of values, right, the pair, in fact, it is a pair, that is a value, two, I mean let us say 2 values, and it will have the unique keys concept as well, it will have unique keys. And next one is a multi-map. So, here the duplicates are also allowed, right. So, it is allowing duplicate keys with associated values. So, when I am using associative containers, what is the advantage, alright. So, I can do the dictionary operations like insertion, deletion, lookup, etc. in logarithmic complexity, right. So, those who have studied or those who are going to study data structures or algorithms, this is order log n, right, n number of elements you can retrieve or insert or you can delete or you can look up or you can update in order log n, right, that means the log n steps, n is the number of elements, correct, in the set or multi-set or map or multi-map, number of elements, alright, and you can do all these basic dictionary operations in order log n time. That means approximately log n steps. So, as we said, right, what do you mean by set? That stores the unique elements in sorted order. We will see an example. And similarly, multi-set, so that is allowing the sorted order, but only difference is duplicates exist, right. What are all the key operations that we can do? Insertion, erase, find, count. So, these are all the inbuilt function occurs. So, insertion means you can add the element and again it will get sorted. Erase will remove the element. Find, it will search an element. Count, what is the number of elements in the set or number of elements in the multi-set, right. So, count the occurrences. So, particularly when you use multi-set, because I talked about the duplicate element. So, there it will be useful, and the main applications are, I mean, you can have automatic sorting and also you can check the uniqueness. Let us take an example, right. So, you will understand much better. So, let us include set, that is another advantage, right, hash include set. So, now you use unique numbers under set, right, which is our set of integers, right. So, those unique numbers, it is under set, you take 10, 20, 30, 20. So, I am using the duplicate elements also, right, duplicate element 20, right. So, this is my initial set and then I want to insert. So, I have included set, right. So, there is no duplicate and it will be in ascending order. This is what we studied. So, what we are expecting? So, even though you have defined this, you will have 10, 20, 30, right. So, you will have 10, 20, 30 and then you are inserting 40, right, the unique numbers object, right, which is invoking insert member function, inbuilt function under set, and then you are inserting the element 40. So, when you are inserting an element 40, 10, 20, 30, 40, right, and we know, so this will be in ascending order. So, unique numbers, correct, this base address will assign to the address of number, and when I want to print the number, right, it is nothing but star unique numbers of, in fact, unique numbers of 0, 1, 2, 3, etc. So, that will be assigned to number. This we had seen in the last program. So, number, so 10, 20, 30 will be printed, all right. So, in fact, when I run the code and then endl, you will go to the next line. So, in fact, when you run the code, you can see the output 10, 20, 30, 40. So, we can check the code also. So, using set, I will just go to the C++ compiler, same example 10, 20, 30, 20 and then I am inserting 40, alright. So, when I run the code, you can see the output, yeah. So, 10, 20, 30, 40 as the output. So, you practice, right, you include all these header files and you can keep on practicing. So, we had seen several, right, STL and set is one of them, right. So, anyway, I have given the detailed explanation, all right. So, the set, we know that it stores a unique element and it is in ascending order, and the duplicates, yes, it will be ignored because 20 is appearing 2 times, right, first index and third index. So, it is being ignored and the loop is iterating to all unique elements. So, in fact, we got the output, the unique elements. So, there are scenarios, all right, where duplicates are not allowed, all right. So, you cannot enter the same mobile number for 2 different persons, that is a practical scenario, or you cannot assign same enrollment number for 2 persons, correct. So, these are all the scenarios where you can use the set. And the next example is a multi-set, all right. So, what we have studied here, duplicate exists. Even if duplicate exists, the elements will be in sorted. So, again you are including set. I define duplicate numbers under multi-set class of integers. Duplicate numbers is a object. So, that contains 10, 20, 20, 30. Duplicate exists, 20 is a duplicate. Now, I am again inserting 20. So, the set contains 10, 20, 20, 30 and then I am inserting 20. So, when I want to insert 20, what will happen? I will get the output like this. I should get the output like this, 10, 20, 20, again 120, then 30. The reason is it has to be in the sorted fashion, alright. So, after inserting 20, it will be in the sorted fashion, and when you are printing this, correct. So, duplicate numbers object, you have the corresponding address in number and the number when you are printing, right. So, this particular for loop you are getting, this is the output, correct. So, in fact, when I run the code, I will get the output like this. So, it is allowing duplicate elements, alright. So, in this case it is a multi-set is allowing duplicate elements, that is the difference between the previous case and only set, we use only set, right, that is the difference between set and multi-set. So, here 20 was appearing multiple times, but still it was working, alright. So, and of course, the loop iterates through all the elements including the duplicates, and there are scenarios where the duplicate exists. So, at that time what you can do, it is advisable to use multi-set. The next concept, map and multi-map, right. So, key value pairs. So, map, as I said, so it will have key value pairs. So, you will have pair, maybe the name and age, name is a string and age is an integer, and then you can find the unique key, and the unique keys are in sorted fashion. And another thing, multi-map, it is also a map, but it is allowing the duplicate, like exactly how we define set and multi-set, right. So, multi-map is also allowing the duplicates like a multi-set, right. So, it is a key value pair. So, here you have several operations under map and multi-map. You have insert, you have find, right. So, insert will add a key value pair, find will search us for a key, and then erase, remove a key pair, right, it is like a delete. Count, what is the occurrences of a key, alright. So, since duplicates are allowed in multi-map, so this particular function count, which is counting the occurrences of a key, which will be useful, right. So, when you have a lookup table, there are many applications where you have a lookups. So, in that particular applications, when you are using the map or multi-map, so this will be useful. So, let us consider, right, using map. That means, I am including map apart from your usual IO stream, right. So, here I have age map as an object whose class is map. So, the map contains string and integer. Previously, we had seen only either integer or in fact only one data type, right, set and multi-set. So, here if you see, we have pair, one is string, another one is integer, one data type is string, another data type is integer, and age map is object. So, now we are writing age map of one string name, right, Alice, right. So, age map of one string name Alice, and that is equal to 25, alright. So, let us say this ID or age, whatever, yeah, it is in fact age map, right. So, age 25 is an age, and line number 8 you have age map of Bob, alright, age map of Bob. So, that is equal to 30, right. So, which is equal to 30, fine. So, now these two are being stored. So, now for const auto address, right. So, const auto address, you are having pair, right. So, you are having pair. So, age map, that means the address of age map and the address of pair, right. So, they are pointing to the same location, that is the meaning over here, right. So, when I write Rn equal to, let us say n equal to 10, int address Rn equal to n, alright. So, meaning is address Rn and address n, they are pointing to the same location, right. So, in a similar way, auto address pair colon age map. So, the both are pointing to the same location, right. So, now based on this, if I put C out pair dot first and there is one colon pair dot second. So, pair dot first is nothing but whatever be the string. What is the string? Alice. Pair dot second, it is nothing but an integer. What is the integer? 25. So, the first output I will get, it is a for loop, alright. So, it will move, once it is printing, it is moving to the next address location. So, pair dot first, Alice will be printing, followed by the colon, and then you have pair dot second, which is 25, alright. So, then next, right, it is moving to the next for loop, moving to the next location. So, next location, now you have pair dot first, what is that? Bob, right, followed by the colon, and then pair dot second, the age is 30, alright. So, these two will be printed, Alice colon 25 and Bob colon 30 will be printed. So, now we will run the code, right, because map we are seeing first time. So, what we can do, we will go to the C++ compiler, and if you look at here the map, the same code, and if I run the code, compile and run the code, so you will get the output, right, Alice colon 25 and Bob colon 30, right. So, this is the output we are getting. So, this is the case of map, alright. So, we will see what do you mean by multi-map. right, and this is a explanation I have already given, the map that is storing the key value pair. So, you can see that the key value pairs are nothing but Alice and Bob, all right, and then you have 25 and 30, right, and the keys are stored automatically. Yes, we have seen that when you are printing out these first and second, all right, and if you want to access, right, so I want to find out, let us say I want to print what's Bob's age in that particular example, or you have n number of keys. Assume that you have n number of key pairs. So, if I want to access any one, so it will take approximately log n steps, and similarly I want to insert, correct. So, map that follows a sorting order, right. So, it will be, as I said, it will be sorted automatically. So, when I am inserting, of course, it has to be sorted. So, even in this case also approximately it will take log n times, right, and here we are using the auto keyword, right. So, automatically it will be taking care the data type auto in C++, automatically taking care. So, for example, here we have used string and integer, right. So, if you use auto, auto can behave one case pair dot first, it is behaving for string, right, or it is mapping to string, and pair dot second it is mapping to integer, that is the meaning. So, that is what the idea of using auto. Even you can try, right. So, auto A equal to 10, auto B is equal to 9.8, right. So, in fact, you try to print or you try to find out the size. So, automatically it will tell what is the size of an integer, what is the size of a double or float, right. So, you can write for the float also. So, you can try with the auto keyword. So, the next concept is a multi-map. So, multi-map, as I said, duplicates are allowed, right. So, the duplicates are allowed. What we can do here, the same or similar code, right. So, you have multi-age map. So, here I am having the object multi-age map, and then you have the object multi-map, all right. So, which has string and integer, all right. So, first initially multi-age map is invoking insert, you have Alice and 25, right, Alice comma 25. In the previous case we have done slightly different. I mean, this is also way you can do. I am calling the insert function, right, insert member function, so inbuilt function, Alice and 25. And line number 8 you have the same multi-age map object is invoking insert. Now, you are putting Alice and 28, right. If you do the previous case, map case, I mean it will be overridden kind of, alright, the duplicates are not allowed, alright. Whereas here Alice, again you are having the name Alice. So, what it will be doing? The same we will do auto, right, reference object is pair. So, multi-age map address will be now same as pair, right, address pair, and then when I am printing pair dot first colon pair dot second, right. So, for is initially pointing to Alice and 25, correct. So, Alice followed by the colon and 25 will be printed, right, and you can see the second insertion was Alice comma 28. So, when the pointer moves to the next location, right, you can find the key or pair Alice comma 28. So, that will be printed. So, here the duplicates are allowed, alright. So, we can check that. So, we will go to the C++ code. So, here also I have included map, alright. So, maybe what we can do, we can test the previous case once we run this code. So, it is a multi-map. So, multi-map, when we run the code, you can see what is happening, alright. So, Alice will be printed 2 times, but the age is 25 and 28. So, that means duplicates are allowed. So, what we can do in the previous program, press any key to continue, we will go to the previous program. So, we will just do, we put age map Bob, next one, next line, line number 9, just copy line number 8 and paste it, next line, just put enter, age map, open the braces, yes, same Bob. Now, what we will do, we will put 35, right, this I am testing in equal to 35, semicolon, fine, alright. So, what I did, I included the duplicate. So, now let us see when we run the code, execute, compile and run. So, you can see that, right. So, that was overridden, right, age map of Bob equal to 30, line number 8, right. So, the duplicate we cannot insert. Maybe we will try one more case of multi-map. So, here what we will do, it is already alias, right. So, we know that if I write alias comma 30, that will also be printed. Maybe if you want, we can do that. Multi-age map insert, let us use Control C, enter, Control V. We put 25, 28, 31, right. So, can you guess the answer? You know that everything will be printed, right. That is in the case of duplicate, right. Let us run the code, compile and run, right. So, you can see that alias 25, 28 and 31, right. So, this is the case of the multi-map, the case of the multi-map. Duplicates are allowed, right. So, this is what we have done. This is duplicate keys. In fact, we tested. So, one we tested with the 2 times alias, another one we tested 3 times alias, it was working. Whereas, in the case of map, we tried to put Bob, right, but you can see that whichever the latest you have entered, that will be overridden. So, the duplicate will be ignored, right. So, that is a case of map. So, when there are cases, right, there are practical examples where the multiple values are associated. So, in this case you can use multi-map, alright, and you can see that the loop was iterating through all key value pairs, right, the for loop that we had seen, and in this case it will include duplicates also. So, whereas in the case of a map, so we know that that will be ignored, right. So, case of Bob, right, one time we put 25, another time Bob 30, 25 were ignored, right, that is over because of the duplicate. So, this is the difference between map and multi-map, right. So, in the next lecture, I will start with introduction to unordered containers, right. So, with this I am concluding this particular lecture. Thank you.